equation x equals 4 that we're starting out with, we've been asked to raise it to the second, third, fourth, and fifth powers. Okay, so here goes. X to the second is equal to 16. X to the third is equal to 64. X to the fourth is equal to 256. And x to the fifth is equal to, oh, let's see, I did not write that down. So I'll be calculating that while I am calculating it. X to the fifth. So 4 to the fifth. 4 to the fifth power is equal to, oh, 1024. That's a big number. Okay, 1024. All right, so now it says solve each equation. Okay, well, there we go. Here we go. So when we're solving each equation, we can just, you know the drill, right, people? So plus or minus, do you see there's plus or minus 4, right? Okay. The cubed root of x, well, the only value that will make this a true statement is 4, right? Okay. The fourth root of x, people, it's plus or minus 4. I think you're starting to see the pattern, aren't you? Okay. And then, of course, x to the fifth, the only one that's going to work, the fifth root of x to the fifth, and you can even plug it into your calculator if that makes you feel better, that's going to be positive 4. Okay. So in which case are there extraneous solutions? In general, when could raising both sides by the same power generate extraneous solutions? Whenever you raise it to an even power. Whenever you raise it to an even power. Now, let me just clarify. I think I may have skipped over something that could be kind of important. Notice that our original equation is x equals 4. All right, so our extraneous solution, for example, in this case right here, our extraneous solution is -4. Because if you plug -4 in up here, that is absolutely not a true statement. So that's why we consider that an extraneous solution. Now this one, there's only one solution and 4 equals 4. No problem, okay? So the idea though here is that it's when you raise it to an even power. Now we've been practicing that. Remember when there's been a couple of radical equations, and if you have an x under the radical and it's a square root, then what you end up doing to get rid of that radical is you raise it to an even power. You square it. And that's why you have to check for extraneous solutions, because whenever you raise it to an even power, extraneous solutions can show up.